So we have right triangles. That means that there is a 90-degree angle in there. So right triangle trig is a branch of math that deals with the relationship between the sides and angles of a right triangle. So this whole unit 3, we're going to be looking at right triangles. And basically what we learned today is what we use for the whole unit. So what we're going to be using are called trig ratios. And a trig ratio is the ratio between the sides in a right angle. Okay, in a right triangle, all right. So if you're looking at a right triangle like we have down here, there are 3 angles in a triangle, right? One's the 90, and the other 2 are acute angles. So there's 2 acute angles in there. So if I'm looking at this angle right here, there are 3 different ways I'm going to label the sides. So there's 3 sides, they're all going to be labeled something different. So what do we know about the side that's opposite the right angle? What do we call that?
The leg, or the hypotenuse.
The hypotenuse. So that is always the hypotenuse. Okay. So when we're looking at trig, we're either going to have an opposite or an adjacent side. Adjacent, remember, that means that if they touch each other, remember with adjacent angles, that means they touch. And then opposite just means it's on the opposite side of the triangle. So looking at this triangle and this angle right here, this side is directly opposite it. So that's what we would call the opposite side to that angle. This angle touches this side, so that would be the adjacent side.
Miss Lindsay, not to interrupt or anything, but I'm actually sweating.
I can't do anything about it. I think there's something wrong with the air. Yeah.
You're not sweating?
No, I'm hot.
I was had to go out for the gym.
Okay. So we have our opposite side, we have our hypotenuse, and we have an adjacent. We'll always have those. The hypotenuse is always across from the right angle, but it depends on the acute angle you're looking at, whether the side is opposite or adjacent. So if I'm looking at this angle now, this is still the hypotenuse, but now this side is the opposite, and this side would now be the adjacent. So based off of the angle you're looking at, that's how you're going to decide which one's opposite and which one's adjacent.
Okay, that does not make any sense.
So if I'm looking at the blue angle, there's always 3 sides on a triangle, right? So one of them is always the hypotenuse, and that's across from the right angle, yes. So if I'm looking at this blue angle, there's now 2 other sides that needed to be labeled. If I'm looking at the blue angle, it touches this leg right here. So that means that it's adjacent, because adjacent means it touches. Then the other side that does not touch that angle, because these 2 touch it, this one doesn't, is now your opposite. But it switches when it's looking at this angle. This angle is opposite, that side's opposite to that angle. This side's adjacent. So they just switch based on the angle. So we have our 3 trig ratios that we're going to be looking at. And it's going to be a ratio between 2 of the sides on the triangle. First one we have is sine. That is sine, we write S-I-N for it. That's not sin, it's sine. So the ratio for sine is always opposite side over hypotenuse. So the ratio for sine is always opposite over hypotenuse. And I write it like this. SO over H, so we'll use that when we're given an angle and we only are given the opposite side and the hypotenuse. Cosine is the ratio between the adjacent side and the hypotenuse.
The next one is opposite over adjacent. For real?
And I write that as cos C A over H. And then tangent is opposite side over adjacent side.
So it's a fraction.
Not really.
So
I
like,
mean, every time you write it, you're going to start with a fraction, but you like have to solve it. But yes, every one of the answers down here at the bottom is going to be a fraction.
We're doing fraction.
no.
Not really, it's just the ratio is set up as a fraction, so some of your answers will be fractions. So we have SOHCAHTOA is what I call it, that's how I remember it, is SOHCAHTOA. But opposite side and adjacent side depend on the angle. And the hypotenuse is always opposite the right angle. So, for this unit, we're going to be looking at SOHCAHTOA. All the time.
Are we gonna get decimal? That's what it is.
But you gotta simplify the fraction.
I just keep it fraction. Okay, so SOHCAHTOA, you have to know SOHCAHTOA, okay? So I was taught some old hippie came a-hopping to our apartment. Some teachers teach it, some old hippie came a-hopping, tripping on acid. Like, it's just different ways to remember it. But some old hippie came a-hopping, tripping on acid, or to our apartment. You have to remember SOHCAHTOA.
I'd rather be tripping on us.
However you can remember it. If you can think of another way to remember it, then go for it.
My imagination. So.
So now, looking at this triangle in the example down at the bottom of page 3, it wants us to find the sine of A, cosine of A, and tangent of A. So those first ones are only looking at the angle A. So I'm going to highlight the angle A with blue. Now, which side is my hypotenuse? 3, 4, or 5? 5 is the hypotenuse. Looking at the blue angle, which side is opposite? 3 or 4?
3.
3. 3 would be your opposite side there. And then 4 would be your adjacent. So, the blue is going with angle A. So now, for sine, I need to do opposite over hypotenuse. So my opposite side is 3. My hypotenuse is 5. So my answer is 3 over 5. That's all you have to do. If it's able to reduce, then you would reduce it. So like if it was 9 over 15, you'd reduce it to 3 over 5. But this one doesn't reduce. Then cosine, adjacent over hypotenuse, so 4 over 5. Tangent of angle A would be opposite over adjacent, which is 3 over 4. So we're gonna, right now, when it just gives you all 3 sides and it wants to set up a ratio, that's all it's looking for. Right here, the only thing it's asking for is the ratio. Later on, we're gonna solve for sides and we're gonna solve for angles. So if it just asks for the ratio, this is what you will do. If it asks for you to find a side, you'll actually have an angle measure, and then one of the things in the fraction will be an x. If it wants you to find an angle, you'll have the whole ratio, and then you have to solve for the angle, so you'll have a variable at the a and the c. But when it just asks for a trig ratio, this is all you have to do. So now it wants you to find all of those for c. So hypotenuse is still the same. Now the 4 is the opposite, and the 3 is the adjacent. So sine, we have 4 over 5, opposite over hypotenuse. Cosine, adjacent over hypotenuse is 3 over 5. And then tangent is going to be 4 over 3. Okay, so those right there, 1 through 4, those were just looking at one angle on the triangle at the time. So now the next few, we're going to be looking at both angles. So let's go to number 5. There's 5 and 6. Check your answer. So on page 5, we're going to look at complementary angles with right triangles. So first thing, complementary angles are two angles that add to equal 90 degrees. Okay? So, two angles that add to equal 90 degrees. In a right triangle, one angle is always right, which is 90 degrees. And the other two angles always add to equal 90. They're two acute angles that add to equal 90. Therefore, two acute angles in a right triangle are always complementary. So if I was looking at those two examples, 60 plus 30 equals 90. 20 plus 70 equals 90. So the two acute angles in a right triangle always add to equal 90. So first one is looking at A. So A, 5 is the hypotenuse, 3 is opposite, 4 is adjacent. So sine of A is 3 over 5. Cosine of A, 4 over 5. And then tangent, opposite over adjacent, is 3 over 4. So we found our ratios for angle A. Now we need to find them for angle C. So angle C, this is now my adjacent, this is now my opposite, and then my hypotenuse stayed the same. So now sine of C, opposite over hypotenuse, is 4 over 5. Cosine of C, adjacent over hypotenuse, is 3 over 5. And then tangent of C is opposite over adjacent, so 4 over 3. So looking at those pink ratios to the blue ratios, what do you notice?
With the tan, there's a portion of it.
What?
Tan part,
What about
first, I forgot what it's called, but 3 and 4 go top. So I just bring it down to 10.
Just split. Same equal
It's
size.
like that because that's opposite and that's adjacent. So that's opposite over adjacent. That's why it's like that. But what do you notice about something over here in the pink and then over here in the blue?
They just split back like, you know.
So what do you notice about sine of A and cosine of C?
They equal each other.
They're the same. So I'm gonna write that. So sine of A equals cosine of C. What do you notice about cosine of A?
It equals the sin of.
Cosine of A equals sine of C. And then, what do you notice about tangent A and tangent C? Tangent A and tangent C are reciprocals. So if you think about it, A and C are complementary angles. So if you're looking at it like if A was 60, C would be 30. So sine of 60 equals cosine of 30. 60 and 30 are complementary. So we can find their relationships like that. So just like on the next one, we have sine of 30. So I want y'all to put that in your calculator. So there's this right here on your calculator are the sine, cosine, and tangent keys. All you have to do is hit sine and then put 30. So it should just say sine parentheses 30. And you can hit enter.
Oh.
So it gives you 1/2, or you could write 0.5. So now I want you to put in cosine of 60. So cosine 60. It gives you 0.5.
Oh, I got it.
What do you notice about 30 and 60? They equal each other. Well, 30 and 60 don't equal each other. 30 and 60 actually equal 90. They're complementary angles. 71 and 19, are those complementary angles? Yes.
Right.
And then 30 and 60, those are complementary angles. So let's see, if they're complementary, one's sine and one's cosine, they should equal each other. So sine of 71 gives you this long decimal. So I'm gonna round it to 0.946. And then what's cosine of 19 when you put it in?
0.946.
0.946. Then what's
Oh, what
tangent 30?
Square root of 3/3.
And then what would it be as a decimal?
0.577.
Well,
0.577. And then if you hit the little fraction ND key, you can do 1 over tangent of 60. And it should give you square root of 3 or square root of 3 over 3 or 0.577.
1 over.
So each row is equal. That's what we notice is each row is equal. And the angles are complementary. So sine of 30 equals cosine of 60. Sine of 71 equals cosine of 19. That's basically what we noticed. And then those two equal each other. I just don't want to write that out
So they're both complementary.
because they're complementary angles, yes. So the sine and cosine of complementary angles are always equal. And the tangent of complementary angles are always reciprocals.
Oh my gosh, word problems.
They're just questions, not really word problems. They're not bad.
What page you on today? 11?
Okay, so number 4 says if the sine of 50 is 0.77, what's the sine or cosine of 40? Don't use a calculator.
0.77.
0.77. 50 and 40 are complementary, therefore they are equal, so 0.77. So the sine of 50 equals the cosine of 40. What do you know about the sine and cosine of complementary angles? They are equal. What do you know about the tangent of complementary angles? They are
Equal.
reciprocals.
Same thing, right?
No. Okay, on number 9, if the tangent of 81 equals 6.3, what is the tangent of 9?
6.3.
You're so silly.
Are you sure it's just 6.3?
Yes.
6.313. 75.
So
115.
remember, it's gotta be the reciprocal.
Oh, so it's
So it would be
3.6.
1 over 6.3. And 1 over 6.3 is 0.159 if you put it in the calculator. But it says don't use a calculator, so that's all you have to do. So we gotta remember it's a reciprocal. Okay? So in a right triangle ABC, the two acute angles are A and C. If sine of A is 2 over 5, what's cosine of C? A and C are complementary. So if sine of A always equals the cosine of C. So it would just be 2 over 5. In a right triangle RST, the two acute angles are R and T. If tangent of R is 7 over 3, what's tangent of T?
3 over 7.
3 over 7, gotta flip them. If Sarah knows sine of 11 is 0.19, how can she approximate cosine of 79 without a calculator? Since they are complementary angles, they would just be equal. So it would be 0.19. Okay, so this next one says sine of theta. Anytime you see the little zero with a line through it, that's called a theta. That's the symbol that's mostly used for angles, is a theta.
My baby queen.
So, sine of theta equals cosine of something. So, theta is an acute angle. The other acute angle they have to add to equal 90, right? So, sine of theta would also equal cosine of 90 minus theta. Because 90 minus that angle would give you its complementary angle. So, sine of complementary angles equals cosine of complementary angles. And then number 12, Ted knows that the tangent of 53 is 0.7. Can he approximate tangent of 55 without a calculator?
No,
No, why not?
because that equals 88.
What? 53 plus 55 equals 108,
Oh, well,
which is not 90.
it was,
So since they aren't complementary, he can't.
find the missing sides.
So this right here, I just use this to show you basically that when you're doing the ratios, you can kind of save some time, like we did on the last page. So I'm gonna go back to page 4 real quick, when y'all finish writing these down. And I'm gonna show you how we can use that knowledge we just found to help you out a little bit to solve problems a little bit faster. So, if I go back to the top of, or the bottom of page 4, if I find sine of F, so this is opposite, adjacent, that's not adjacent, that's not hypotenuse. And then this is adjacent. So sine of F will be 15 over 17. So what would cosine of H equal? 15 over 17. Cosine of F is 8 over 17. So sine of h is 8/17. And then tangent is 15/8. So tangent of h is 8/15. So really, you only have to solve for one side. And then you can use that one side to find the other thing. Same thing with the next one. So hypotenuse, looking at angle R, we got adjacent and opposite. So 35/37, 35/37. 12/37, 12/37. And then 35/12 goes to 12/35. So once you find one column, it's easy to find the other one. So we'll label the sides, set up a trig ratio, set up an equation, and then solve the equation. So if I'm looking at that first example, the angle it gives me is the angle 30. So looking at that angle, I'm going to label my sides. So the x, is that adjacent, opposite, or hypotenuse? That's adjacent because it touches it. And then 186 is the hypotenuse. And then the blank side is the opposite side. But since it's blank, we're not really using it. So I can just mark it out or not label it. Because we're not going to need it. So the only two letters we have here are A and H. Which trig ratio has A and H in it? So far, TOA. C.
Oh, cat.
Cosine, top. So that is our trig ratio we're going to use. So we labeled our sides, we set up our trig ratio, or we found our trig ratio. Now we're going to set up an equation. So remember, it's always cosine of an angle equals adjacent over hypotenuse. So I have cosine, COS, of my angle, what's my angle? 30, equals my adjacent x over my hypotenuse, 186. So that is my equation.
We can plug that on the
So step
calculator.
1, step 2, step 3. You can plug it in the calculator, but first you have to isolate x. So to get x by itself, what do I need to do with that 186?
Multiply it.
Multiply both sides by 186. So now I can just plug 186 times cosine 30 into the calculator. And you literally just type in 186, hit the cosine key, 30.
161,
Point
0.1.
So when you plug it into the calculator, you should get 161.1 for x. And that would be 161.1 feet. So this side right here is 161.1 feet. So that's basics of solving for a missing side. But that's when you have x in the numerator, so x is in the top. When x is in the denominator of the ratio, you have to do a little bit different work. You can't just multiply by both sides. So, looking at the second one right there that says x is in the denominator, I have 23 as my angle, and then x, is it opposite, adjacent, or hypotenuse?
Adjacent.
Adjacent, and then 55, opposite or hypotenuse?
Opposite.
Opposite. And then this will be my hypotenuse, but I don't need that.
So, toe.
So I'll have O and A, the only one with that is TOA, so that's what I'm gonna use.
Two. Oh, that was weird.
That was weird.
So I'm gonna have tangent of my angle 23 equals opposite 55 over adjacent x. So this time, x is in the bottom, over here, x is in the top, so it's just one step. Now I'm gonna have to do 2 steps to get x by itself. So the first thing I need to do is get x out of that denominator. So I'm gonna multiply x on both sides. So I'd have x times tangent 23 equals 55. Is x by itself yet? No, so what do I need to do to both sides? I subtract. To undo multiplication, you divide. So tan 23 is a one whole thing that's gonna move together. So tangent of 23, divide that on both sides. So that parentheses 23 sticks with that tangent. You never separate them. Okay? They're married, you can't separate them. Okay, so now you have x equals 55 over
That's a big number.
tangent of 23. And you can put that in the calculator using the ND key,
Indeed. It's
the N over D fraction button.
a big number for a lid. It's not actually accurate.
Yeah, I mean, the pictures aren't drawn to scale.
Yeah.
Okay, so what did you get for x when you put it in the calculator?
129.6.
So 129.6 centimeters. So,
This one tells us where to put the X at. These ones don't.
but you used the ratio. It was just telling you, like, this is an example when x is in the numerator, this is an example when x is in the denominator. So I want you to look at something real quick. What do you notice about this tangent of 23 and this x from the first one to this one? What happened to them?
They got flipped.
They just switched places, right? That's all you have to do. You do not have to show that middle part.
So you can skip it.
All you have to do is just switch the place of the x and the tan 23.
So if you have total, you can just flip it with and take
So-
off the number.
It's not just with tangent though. Anytime you have x in the denominator, you can always just switch the trig function with the x and move it in its place. But if you forget that you can do that, you can always show that work and do that work.
It's not gonna be cold here now.
So like, number 2 is one where you have to switch it. Number 1, you don't have to switch it. So looking at number 1, I've got my angles 44, and then I've got 2 sides. So 18, adjacent, opposite, or hypotenuse? Hypotenuse. X is
Adjacent.
opposite.
Oh, yeah.
And then this blank side will be adjacent, but we don't need that. So if I just have O and H,
SOH.
I'm gonna use so sine. So I'll have sine of my angle. So sine of 44 equals my opposite over hypotenuse. X is my opposite, so it's on top. My hypotenuse is 18, so it's on bottom. So sine 44 equals x over 18. So to solve for x, what am I gonna do to both sides? Multiply 18 and put it in the calculator.
That's accurate. Okay. 12.5. Is that right? Yeah.
So when you put it in the calculator, you will get 12.5 inches.
How do you put it in the calculator?
So what I would do is I would just type in 18. So just do 18, then hit the send button right above the 7, sine 44, and hit enter.
Thank you.
Okay. Now number 2, we've got angle 58. We've got X is our hypotenuse. 30 is adjacent, and then the blank side's opposite, but we don't need that.
Wait, can you do the same as when you did,
That's good enough.
as a, when you did a pop?
Yeah, right above. So I'm gonna have A and H, so that means I have cos. So I'm gonna have cosine of 58 equals my adjacent 30 over X, which is my hypotenuse.
Flip it.
Since X is on the bottom, and you can't just multiply both sides by 30 to solve for it, you're going to switch the place of the X and the cosine. So now instead of being cosine of 58 over here, it's just gonna be X. And then 30 over cosine 58. So basically, all I'm doing is switching those two.
56. Point C.
Then in your calculator, I would hit the little fraction button, then do 30 on top, and then cosine 58 on bottom. So it'll look exactly like what you have written when you put it in the calculator. And it should give you 56.6 millimeters.
Alright, we don't get it at 11.
Huh?
They don't get it at 11.
I think it's tomorrow.
Yeah, I think we're taking a really long time.
Okay, because tomorrow it also says pages 7 to 11.
Yeah. We don't finish
Why
that.
did you say 11?
I didn't know how fast we would get through it, and y'all are probably gonna move a little bit faster than my other classes.
That part, yeah.
Okay, so on page 8, we're going to practice with this. So, looking at page 8, we can set these up and we can solve using SOHCAHTOA. First thing we gotta do is label the sides, find our ratio we need to use, set up the equation, solve it. So again, this is one where X is in the denominator, and we're gonna have to switch the place of the X and the trig ratio, or the trig function, not the trig ratio. So, what I'm gonna do, I'm just gonna switch it, so now I have X equals 12 over tangent of 66.
You just put the double.
So when you put that in the calculator, 12 over tangent of 66, what did you get out? X equals 5.3. One, we'll have angle 75. We've got our hypotenuse is 48, our opposite is X. So I'll have so, and I'll have sine of 75 equals opposite X over hypotenuse 48. To solve, we'll multiply both sides by 48. And when you put that in the calculator, it does give you this 12 squared is 6 plus 12 squared is 2. That's not the answer I want. I want decimals, so you'll hit the little double arrow key. This little key. And it should give you X equals 46.4.